Let's now talk about scalability. There will be certainly a time now where your workload will grow and you want to scale your cluster. Now, there are two ways to do this. Either you can go in a manual way by inspecting things like CPU and other metrics and taking a decision upon that, or you can use autoscaling. The recommended way that we are having for this architecture will be to go through autoscaling. If we take a look at how this would look like, you would have a node here. So let's say this is node 1, and then a second node, node 2, on a specific virtual machine scale set, so in a specific node pool. When you do this in a manual fashion, what you're looking into is this. You'd have, let's say, a pod running on this node, and then another one on this node, and then another one here, and so forth and so on, knowing that it can only scale so much. Now, one way to manually scale for more pods would be to inspect and look at CPU utilization and see, hey, do I have enough CPU? Can I put more? I can't. Am I hitting a bottleneck? And then changing the replica set for those for the deployment, and which would translate really in more or less pods running at any given time. Now, another way to look into this and do a cluster scale, which you can certainly do it manually, would be to inspect whether or not the Kubernetes scheduler is failing. So imagine that you now have a separate workload running here too. So as we add more, what might happen is the scheduler, and let's suppose we can only accommodate 6 pods in our example here. The next time I'm trying to now say I need to scale and have an extra pod, it might not just work due to the lack of resources. So as the scheduler tries to come here and say, hey, you ask the scheduler to put an extra workload, well, there's really not enough resources, whether that's CPU or not, you can't really do it. So as the scheduler tries to go and inspect the nodes and say, well, I can't really do this, it will fail. So one way is to look at those logs. Now we can automate all of that with Autoscaler. Now there are 2 approaches in here. For a pod specifically, we can use something called an HPA, so a horizontal pod autoscaler. That's a Kubernetes resource. And what it does for you is it will scale based on some boundaries that you pass to it. So we have a minimum and a maximum amount of replicas, and based on, by default, it only works on CPU. That's the default metric that it allows, but you can extend this. With CPU, you would say, give me a minimum of 4 of these pods, a maximum of 10. If the CPU goes above, let's say, 80% or 50%, then you scale up or down. So with that, what we're tackling here really is this. So it's the scaling in and out of pods within the nodes that we have. We're not really triggering the creation of new nodes, just the pods. If, for instance, another approach would be if your workload is based on an event. So let's say if we look at our picture here, and let's suppose we're using a queue. So I'm just gonna create a queue out here, and let's suppose depending on how many items we have, or items that arrive in that queue, or the behavior of that queue, we want that to trigger an event for our scaling either up or down in our cluster. We can use an open source project called KEDA. So with KEDA, and I'll link that in here, you can actually look at that event. So it's an event-driven autoscaling, and then that will translate back into actions that can be taken into the cluster. So that will take care of pod autoscaling for sure. Now, the other thing we want to take a look into is, even if we do have HPA running and we are taking advantage of scaling in and out within a cluster, there might be a time where I really need an extra node. For this, we have a cluster autoscaler, which is an AKS add-on component, and it will essentially scale more nodes within a node pool. So that's an important thing to have in mind. When you're enabling autoscaling for the nodes, so suppose again we go back here and we need an extra node. So let's create here node number 3. That's on a per node pool basis. So that's how this would work out for us. Now, once that's done, the cluster autoscaler can do the following for us. It will automate a lot of the things that I've mentioned. So it will check whether the scheduler is failing to schedule new pods, and then it would trigger the creation of this new node so that you can accommodate more workload. The reverse is also true. The cluster autoscaler will check for unused capacity and will essentially, terminate those nodes. So let's suppose node 3 now is no more needed. You can terminate that, remove this from the cluster, so you are minimizing your costs as well. By what we have here, you do need a maximum and minimum node count. Similar to what we do with HPA, you do that for your cluster autoscaler as well. So let's suppose we need a minimum of 2, which is what we really have for this architecture. We're looking at, give me a minimum of 2 nodes for this workload. And then for the system node pool, we're looking into having a recommended minimum value of 3 nodes. With this operation, you can really save a lot of the management of this performance and scalability. So setting up HPA for pods specifically, and setting up a node autoscaler for the cluster itself. So there are 2 different approaches that we can take in here. Let's take a look at the command here just for HPA, and let me illustrate how that will work. If we bring this here, and let's just change for X11. So what we're looking into is the following command. You're issuing a command against the Kubernetes APIs to enable autoscaling. So you can see autoscale deployment. I have a deployment here called tkasari.net. So just a deployment for an example. The max amount of pods I'm looking to is 10, and then the minimum would be, let's suppose, 2. Now, as I mentioned, you only have CPU as your out-of-the-box metric for HPA. So I'm going to set the CPU here to, let's say, 50. And now I have that deployment autoscale. So if I do kubectl get HPA, I can now see that I do have that minimum number of pods, the max amount of pods, and it was just created now.